everyone, we're going to establish the following identity. Sine of alpha minus beta times sine of alpha plus beta equals sine squared alpha minus sine squared beta. And we're going to use sum and difference formula. So the first part is we're just going to expand this. I'm going to use expand it this way for the first one. So that's going to be sine of alpha times cosine of beta minus cosine of alpha sine of beta. And then for this part, I'm using this. So that's going to be sine of alpha cosine of beta plus cosine of alpha sine of beta. All right. It has this form here, difference of squares. So basically what we have is we have a minus b times a plus b, and that just equals a squared minus b squared. So that's all I'm going to do. I'm going to write it this way. So I'm going to square this. That gives me sine squared alpha times cosine squared beta minus the b, and this is our b. Our b's are the same, so we can do this. Cosine squared alpha sine squared beta. Now at this point, we're going to have to fix this up a little bit because we don't have a cosine in our identity here. So I'm going to rewrite these cosines. So I can write like cosine squared of theta equals 1 minus sine squared of theta. So I'm going to substitute my cosine squares with 1 minus sine squares. So that's going to give me sine squared of alpha times 1 minus sine squared beta minus, then we have 1 minus sine squared alpha times sine squared beta. Now at this point we're going to distribute, so we get sine squared alpha, and I'm just distributing here, minus sine squared alpha times sine squared beta. And then when you distribute here, I'm going to go ahead and add all this together and get minus sine squared beta. And then two negatives make a positive. And that's going to be sine squared alpha times sine squared beta. Now simplifying this, these two cancel, the zero property, and we're left with sine squared alpha minus sine squared beta, which is our desired result. Thank you. Have a nice day. Bye-bye.